Hi, this is Walter Moreno. Today I'm gonna be presenting designing effective visualizations, engaging interest, and improving communications. This presentation is part of the COMP 648 Advanced Topics in Human-Computer Interaction course. Um, Information in different formats is stored every second around the globe in different type of systems and hardware. These large amounts of information are captured by transactional systems, social media applications, internet browsers, memory sticks, barcode and imaging scanning, emails, voice recording, paperwork, among many other ways that can be captured information. So the aggregation and summation of this information is important in order to get insights and knowledge about the information that we capture. Um, so designing effective visualizations is relevant when information needs to be presented and how information increases the user engagement and improves the communication channels. Within the literature review, I found that there are some uh, categorization of roles for the visualizations. One is the quick verification of correctness, quick delivery of simulations results, and also it helps to understanding by one of the roles is understanding by lay audiences. Mm, the adoption of visualization methods in designing have some advantages as well. So visualizing something externalize your understanding. Basically, is externalizing internal understanding aids the sharing of knowledge. Visual artifacts help to store mental presentation physically. So creating visual artifacts helps to relieve a person's work's memory, therefore improving their thinking capacity. Um, and the visual artifacts can group together relevant information. So grouping together relevant information can clarify how ideas and concepts are related. Mm, so visualizations is one of the most important components of research presentation and communication, based on the ability to synthesize large amounts of information into effective graphics. Um, Visualization is especially useful when there are none or some knowledge about the information to explore. So when there is no information, no knowledge about the information that we captured, there are so many questions that we make to ourselves, and we try to dig into the information and try to find answers to these questions. So if we know already what is the output of that information that we are collected, well, it might be not useful. Um, Visual data exploration follows a three-steps process comprising overview, so zoom and filter, and details on demand. The zooming part is the higher level of aggregation of the information. Um, and then the filtering is lower levels of aggregation of the same type of information, and the details on demand will be use the raw data uh, or the raw information that we are looking at. In this context, visual exploration can be viewed as a hypothesis generation, and it allows the users to be interactive and achieve and adjust analysis goals for data exploration or for analysis. Um, Also, user behavior information displays all 5 V's, the core 5 V's that are volume, velocity, variety, value, and veracity. Um, About this core 5Bs, I have found it also in other publications that there are more than 5Bs, but I have selected these ones. They were included in some of the literature review, and so the volume expresses the amount of information that we collect. For example, Facebook can generate over 5 new profiles every second, and more than 136,000 pictures are uploaded per minute, and the same with the comments, about 510 per minute. So that is talks about the volume. The velocity refers to the speed that this information navigates through the networks, how is from when it's collected, generated, collected, and analyzed. There are some limitations on this, also based on some geographies, countries, limitations, economic limitations. So there are places that they cannot upgrade their network. So this velocity of the information, or this speed of the information, gets restricted in some areas, and there are some constraints for that. The variety, it refers to, in some extent, to the origin of the, sorry, variety. It refers to the different type of information that we use. So new devices, new technologies, they require new applications. Value is it refers to the importance of the information that we are using to solve a problem or to bring a solution. And the veracity, it refers to, in some extent, to the origin of the information, and the sources, if are reliable or not. So this is an example of big screens that have been used to develop big data visualizations. This is the Data Science Institute, Imperial College in London, and I thought it would be interesting to show how they represent, or they show, displays the results of big or data visualizations. The methodologies to discuss today in this research paper are there are two methodologies. The first one is the power of large-scale visualization combined with a fuzzy logic in order to perform effective data explorations in big data sets. And the second one is the hierarchical aggregation in visualization. Basically, the aggregation stored in any visualization into a multi-scale structure that can be presented at any level of detail. So for the first methodology, the research focused in two variables defined over the graph, the degree and the weight of a node, and the two selected variables were defined as linguistic variables. Low, medium, and high were the values. Linguistic variables are less specific than numeric values, but much closer to the way humans express and use their knowledge. They employ a fuzzy rule-based system to perform such inference in order to identify what are the interesting nodes. So within this study, I'm gonna present it in a moment. They did 3 cases where they were using different type of data sets with large amounts of information, and they were presented in using graphical interfaces, and they were identifying which nodes had more concurrency within the large amounts of information. For the second um, methodology, hierarchical aggregation. It was presented used different data mining techniques to applying algorithms and methods um, for aggregation. So they also identify how the information or large amounts of information can be drilled down or drill up, depending the way that we want to see the information. Um, Terminology is important in the design of this process of visualizations, as the hierarchical aggregation groups um, might be um, the, the measures that can be used. There might be meaning different things, even it's the same type of information that we are presenting. Also, the the type of approaches when we are applying these aggregations. Some of these aggregations that can be completed at the database level. So, like there are functions, or sometimes they can be performed on the fly. For example, calculate the age of a group of people. So it can be done using different type of tools. So again, building these visualizations is important to identify the level of the detail that we're gonna be aggregating, and the meaning of the information that is gonna be presented. Now, within this methodology, they use different type of visuals, like scatter plots, and they try to identify which ones were better with the different type of information that are presented. Okay, so let's these are results for the first methodology. So they try to find the coappearance networks of characters in the node of Les Miserables, and the fuzzy query is described at the bottom. So if degree is high, then interest is high. They also did it for the lower, so if the degree is low, then interest is low. And the grid dots, they show where there are more concurrency in the nodes, and then it follows the blue ones and then the red ones. And they did also this analysis for they use data from the Marble heroes, and the amount of nodes that they collect with these styles, it was incredible. So this visualization has 10,500 nodes and more than 225,000 edges that are represented here. Okay, so the second test case was discover biggest contribution in Wikipedia to demonstrate the potential of influence fuzzy queries in large-scale visualizations for gaining quick insights into the information. So again, the fuzzy query is at the bottom. If the degree is high, then the interest is high. If the weight is high, then the interest is high. For this analysis, they use 3 different type of nodes: topics, editors, and editions, and it was used for one section of the Wikipedia that they were looking at. So the blue dots are the ones that are they show more concurrences or points of interest. So that was the second one. And the third one was exploring potential of fuzzy queries and large-scale visualizations for data exploration in data sets of bitcoins. Bitcoins are digital currencies. There was a news this week about bitcoins, and the fuzzy query that they define is at the bottom. So were similar results, and so what is interesting of this one, the red line that is in the graph, is showing some issue with the information that it has been recorded. So again, visualizations help to discover those details, and it provides some insights about the information that is collected, even in this type of large amounts of information that are collected in these systems. Okay, now for the aggregation, for the second methodology that I was describing. The aggregation is for a given set of data items. Hierarchical aggregation is based on iterative building, so it repeats. Rendering is the hierarchical aggregated visualization of amounts traversing the visual stage hierarchy. So the example is at the bottom. So we have about traversal, so it selects the higher nodes, and the lower nodes doesn't look at them. Now the below traversal will be the lower aggregation of the nodes. Also there are level traversal that is used for one nodes that are at one level, and also there are range traversal that are nodes that are between some parameters that can be specified within the calculations or the algorithms or the ways that we are used different methods for data mining. Another fact that another interesting factor that they present in this methodology is that they did some surveys, the existing example, after surveying existing examples to support aggregation in visualization technique, they define a set of general guidelines for designing and implementing such techniques. So entity budget, visual summary, visual simplicity, discriminability, fidelity, interpretability. So they identified these guidelines to help with the design process, and again the understanding of the information from the developer side and also the users that they interact with those visualizations. Okay, some of the conclusions. Combination of large-scale, high-resolution visualizations environments with fuzzy logic can provide a value tool to gain understanding of and insight into big data by means of very simple human-like queries. We mentioned that there are limitations on some networks around the world because there is no sometimes we find constraints on the support of those networks. The guidelines GC, that is interpretability, which states that thinking in aggregation too far might cause misinterpretation. According with the guidelines G4, discriminability, we must now make sure that aggregates and items can be easily distinguished. So again, it's important to know the terminology of the different measures that are presented at different levels of aggregation. Other thoughts that I have about these methodologies that I've been presenting today is based on the um, information that we put into the visualizations and the sources that we use to generate the visualizations and and uh, and also the feasibility of the information that we are presenting using data visualizations. It's important to identify all these details when we are going to design or provide information for users or even interact with visualizations. So that is my presentation for today, and here are my references. And thank you for listening.